My extra credit project focuses on the physics of falling cats and attempts to explain how a cat always lands on its feet. Why is it that research shows that cats land more safely and gracefully from a fall of over 7 stories than one of less than 6? I use the definition of acceleration to examine this phenomena. French scientists were also interested in cats' landing abilities. They found that cats have vestibular balancing organs in their inner ears, flexible spines, and a so-called built-in parachute. Veterinarians in the late 80s found that when cats reach their terminal velocity, the vestibular organ cuts off and the cat's body relaxes, allowing for safe landing. In my simple experiment, I first used VPython to generate data from an ideal system that falls straight down with just the force of gravity acting on it. The following slides show the data that I found from my experiments, first in a graph form and then in a table. As you may have seen from the preceding slides, the highest maximum velocity was reached when the cat fell from the toilet from a height of 16 inches. This was the shortest fall that the cat had, and the maximum velocity was 5,915 meters per second. The lowest maximum velocity was 2,955 meters per second and was reached when the cat fell from the chair. The take-home message from my experiment is that the maximum velocity was reached the fastest when the height of the fall was the greatest. Thus, we can theorize that the higher the fall, the faster the cat will reach terminal velocity and can respond by relaxing its body to land safely. These theories are based on the definition of acceleration. We care about this study because veterinarians and animal health researchers benefit from this knowledge so that they can know when a fall can be fatal or dangerous for an animal and predict how the cat may respond. I do think it is important to discuss the weaknesses of this experiment as well as its strengths. The model that I used was a real living animal, so it does reflect what actually would happen in nature. And Tracker allowed for me to gather exact values and not use approximations. The experiment was, however, limited by the number of trials and the variation in heights due to safety and ethical concerns for my cat. Also, terminal velocity obviously cannot be reached by these heights, so the behavior is more theorized and not fully supported. Also, the model did not account for air resistance or the force of the cat jumping, only the force of gravity on the cat. That is the end of this presentation. Thank you for watching. I hope you enjoyed it.